Hardware control unit. Generally, computer mainly contains three components: CPU, I/O devices, and memory. Again, CPU contains three important contents. What are those? ALU, registers, and control unit. Coming to this hardware control unit, generally we can organize the control unit in two ways. First one is the hardware control organization, and the second one is the microprogrammed control organization. In this we will discuss the hardwired control organization. So means the logic hardware control organization means the logic will be implemented with the help of hardware components. What are those hardware components available, like flip-flops, decoders, encoders, and some other machines? Means it is always implemented with the help of hardware components. This hardware control organization is very fast. Why? Because we are using some logic gates so that we can perform any operation very fast manner. And then another drawback is also there, that is, if we want to perform any modifications on that, then we can modify all the gates, and we have to modify the connections between those gates and flip-flops and connections between those. So this is very difficult problem. So how the control unit is designed with the help of hardware components? So first of all we will discuss what is the input from the input to the control unit. First we will discuss the instruction set. An instruction will be read from memory. That instruction is stored inside the instruction register. So we already know the instruction register. The size of the instruction register is 16 bits from 0 to 15. So 0 to 11, the first 12 bits are used to store the address of the instruction, or address of the opcode, address of the operands actually. Whereas the bits from 12 to 14 denotes the opcode, and the 15th bit specifies the direct or indirect bit. If 15th bit is 0, it indicates the direct addressing. If 15th bit is 1, it indicates indirect addressing. Here the representation is this one: addressing mode I value, opcode value part 2. The size of opcode is 3 bits, and then operand or address, the size is 12 bits. Opcode specifies operation to be performed. So the size of the opcode is 3 bits. Totally we can perform 2 power 3 operations. That is nothing but the 8 operations on the computer. In order to perform these operations, we have to decode those 3 bits by using a decoders. So totally here we given 3 inputs. That means we can perform totally 8 operations. So that is represented in the form of this one. By using the decoder, we will get the inputs to the decoder. The inputs to the decoder is the 3 bits of opcode. Here 12, 13, 14 bits are given input to the decoder as input, and then the size of the decoder depends on the inputs. If suppose n inputs are given, then it produces the 2 power n outputs. So here we have taken the 3 inputs, so it produces 2 power 3 outputs. That is nothing but the 8 outputs. So decoder produces 8 outputs as D0, D1, D2, and so on D7. Those outputs are passed as input to the control logic gates. And the next one is the address. The size is 12 bits. These 12 bits specifies address of the operand, where the operand present in the memory. Those 12 bits also passed as input to the control logic gate. These 12 bits represents the that means these 12 bits are store the address of the operand. Those 12 bits also given input to the control logic gates. And if the indirect bit, this one 15th bit is transferred to one flip flop, this bit also passed to the control bit, control logic gates. If suppose assume that the opcode value is 001, means here we mentioned the size of the opcode is 3 bits. So 3 bits, how can we represent? From 000 to 001, and then 110, and then 111 up to 111. So it depends on the register type. First register type 011, second register 3 ones, third register type also 3 ones. Let us assume that we have to perform the 001 operation. 001 operation. 001 means add operation. Add operation. We need to perform the add operation. Whenever the opcode is 001, then the decoder output is D1 is activated. So 001. 001, we already said 3 inputs, 000 to 111, total 0 to 7. So D0, D1, D2, D3, D4 and so on D7. So here we are taken the input 001. 001 means D1 will activated. That D1 signal is sent as input to the control logic gate, so that the control unit instruct the CPU and memory to perform the add operation. Now we have a sequence counter. So size of the sequence counter is 4 bits. 4-bit sequence counter. So 4-bit sequence counter means it produces 16 timing signals. That means 2 power 4. 16 timing signals 0 to 15. For that purpose we are using a decoder. So 4-bit sequence counter is decoded with a decoder. 4-bit sequence counter is decoded with a decoder. So we get all the combinations. The decoder accepts 4 inputs and produces 2 power 4 outputs. That is nothing but the 16 outputs. All these outputs are passed as input to the control logic unit or control logic gates. First signal is T0, second signal T1, the timing signal T0, the timing signal T2 and so on, timing signal T15. Those all 15 timing signals, that means 0 to 15 timing signals are passed as inputs to the control logic gates. And the next one, the sequence counter have again 3 inputs: clock pulse, clear and then increment. Whenever the clock pulse is applied, then only we can perform the operations. Whenever the clock pulse is applied and INC is also activated. So first clock pulse is T0. So after the T0 execution, it moved to the T1. At that time the increment clock pulse enable. So increment enables, it will increment the time signal. So T0 to T1. After that T1 to T2. Then we will get the timing signal next timing signal. That is, if we are executing in T0, next timing signal is means T1. So whenever the CLR, that means clear control unit, whenever the CLR is enabled, it will get the starting timing signal. It means the sequence counter is cleared. So whenever the sequence counter is cleared, then the process will start from the starting timing signal, that is T0. That means we are in the T4 time signal. So we enable the clear, then it will clear all the timing signals and it starts again from the T0.